Hi, welcome back to writing a little mini Rust in Rust. This is video 9. We have got ourselves a kind of a programming language that can add two numbers together, and it actually works, and it works approximately the way Rust works, which is our idea. So we can pass in a program like 45 plus 13, really an expression, not a program, and tell it to evaluate it, and it will print out the answer, which is 58, and it's wrapped up in some type information, but it's basically working. So in it, we've got like a calculator, right? We've got a working program, but it can really only do that one minimal thing. But yeah, so before we move on to fleshing it out so it can do more stuff and do things like handle not having spaces in the places it's expecting and stuff like that, which at the moment it struggles with, we need to make sure, because I've sworn to myself I will not implement this without getting error handling right. And we got error handling right for lexing, so we have some very nice error messages for lexing. You can see from our tests here, we print out like, oh, I didn't expect that character to be in this position, and it comes out really nicely. But for our parser, we passed over it and said, we'll come back to that. And now is the time. We're going to come back to it now, and we're going to make it right. And the way we're going to make it right is with, by making this, error that we've already got, this unexpected end of file error as an example. Interestingly, I don't think unexpected AOF is the right answer here. If we're really saying 3 plus, that's not an unexpected end of file, that's an unexpected token, I guess. So I guess this will be an unexpected token. Do we have an unexpected token error? We do. That was just a typo, I guess, or something like that. Copy and paste error. Yeah. So in this case, we got a 3 and a plus, which is fine, and then we got another plus, and that doesn't make sense. We expected a 3 or some other number to come in here. So we're returning an error. We're already doing that, but what we're not doing is saying where in the code that error happened. And we think that what we need to do that is to allow our token to remember where in the code, I guess the token is now called right. To know where in the code it exists. So somehow this token needs to have something in it called something like span. Maybe this will be a method because token is an enum, so it doesn't have properties in that way. Or maybe it's going to become, token is going to become a struct that contains an enum. We'll see. We'll see. Okay, so let's leave it for now, because I think that might be what's going to happen. And also, we're going to need the source code, which I guess we could get from token as well. Or maybe the parser will have it. So how does the lexer know the bit of source code it's in? Yeah, so the lexer itself has this thing called input, which is the source code file. Like it's the whole string or str of the source code that it's currently lexing. And that's really useful for error messages. That's why we have the whole thing instead of it just being a stream of characters coming in. So I actually think the parser needs to have one of those too. And that will just simplify that bit really easily. Now we called input, we called the iterator of tokens that the parser deals with input. And in lexer, we called this string input, and I feel like I want the same name between them both. So I think I want to call them something like file content. So let's just rename them here. File contents. And that should be renamed here as well, I guess. And I guess maybe we should rename the input in the parser to tokens, and rename it this as well, tokens. And we're going to need to have not just tokens, but also file contents. Does file contents come before or after tokens? I'm going for before. I probably, if you asked me in 5 minutes, I'd probably change my mind and say it came after. And there's going to be a file contents in the parse struct itself, which means that parse needs a lifetime. So this is going to get a bit annoying. We have to do things in quite a lot of places, I think. Yeah, like here. So basically, whenever you, as a struct, you hold on to a reference to anything, you have to say what lifetime that thing has, which means you need this in your type, and then everything that uses you has got to use it. All right, let's just get rid of this for a second and just go back to what we were doing before, which is pretending that it's always at one as the first character. We don't need a rest break. And let's continue fixing our compile errors. So yeah, again, every time we mention the parser now, it needs a lifetime. I'm just thinking, does Alexa already have a yeah, Alexa already has a lifetime. So this goes together with that. It's nice. It's nice. It's right. It's right. And when we parse, we don't only need to pass in the tokens, we also need to pass in the file contents. And for this test, we'll just pass in an empty string. All right. Is it that easy? Is it still going to compile? Let's just check our test still pass. No, because there's other places we call parse. Like in main. So here we need to pass in whole input. And I think I want to rename it to file contents here as well to make sure we're being consistent. And that's just going to make it so much easier to understand what's going on. I feel like this should be in a function because I don't like it messing up my code here. Let's just have a to-do. Just extract this into a little function. For some reason, it just started annoying me. There's too much mess here. That's what it is. Okay. Yeah, other places where we call parser, I guess in evaluator is a place. So again, just for tests, which are just gonna panic if there's an error. We don't need the error messages to be all perfect, so we don't need to pass in the file contents, the correct file contents here. I mean, we could. Why don't we? We could. We just pass in input, right? So why not do that? Let's do that in this other one as well. Much better to actually pass in the real input, just in case something does go wrong. Okay, file contents is not used, but we're about to use it here, because the whole point of this is that we need the full file contents in order to make a nice, pretty error message, and we actually have to turn it to a string, which is a little annoying, but there we go. Okay, so that was just the file contents, and now all our tests pass. So that's not great. That's just the simple bit, and then the harder bit is how do we get tokens to know where in the file they live. So for that, we need to write some tests, I think. Soon we're going to need a test for the parse error messages as well, but yeah. So when we make a token, it's no longer just going to be a string saying what the literal that we were referring to is. In fact, we could lose that literal now, because actually we're going to give like the position in the file that literal's got from. So we could always re-extract it back out, but it's fine. It's convenient to have the actual literal. although it's a string, so we're actually taking a copy. So maybe we don't want that literal anymore, especially given that we're not using it for much. So let's think about that. Let's think about that in a second. Let's not think about too many things at once, Andy. So do we need these string literals, since we have the location of the literal in the file contents? Do we use them anyway? Okay. So I've said we got that, but we haven't actually got it because we're about to have it. So there's ways we can do this, but I think the right thing to do is to change the token to be a struct and then have a token type, which is this. But it's going to be a big change, but there's going to be shared stuff that all tokens have, and I think the simplest way, rather than storing the same stuff in each variant and then having a method that pulls it out, which would be the other way, we should do it the kind of straightforward way, even though it's going to be annoying to change our code. So there's going to be some kind of type. We could just call it kind, and then could call this token kind. Maybe, and then kind will be of type token kind. So I'm using the word kind to avoid using the word type because that can be problematic. This should be a struct. So this is the kind is going to contain all the information that we previously had in the actual token thing, and along with that we're also going to have, I said span, which is going to be, I think, a usize, comma usize. It's basically something that can be converted. If we look at where we need this, in the error code, we need something that we can call into on, which allows us to create a source span, which is a miet concept, basically saying where in the code was this thing, so that we can print a nice error message for you. So 2 numbers seems to be what we need. So now we've done this. Assuming this was a token, this token thing, yes, it's a token. Oh, hold on. It should be label colon. Yes, yeah, like so. Now, it's annoyed about span, because span is private, it should be public. I think this should be public too. I don't see any reason for methods to expose this stuff. Let's just do it as it is. And then everywhere where we create these things, we've got to change them. And I'm really wondering, do we need these literals? If we deleted them at this point, it would slightly simplify this code. But in order to actually construct the int, we'd need to grab it out of the original input string using our span. So that's going to be complicated. We'll do that later. Well, maybe we'll do it, but we'll do it later. So this is going to be, we're going to create a token. Oh, come on. Which has a kind of token kind int. And some kind of span. For a second, we'll do a span which is just 1, 1. We'll do things step at a time so we can get these things compiling as quick as possible. And what have I done wrong? Oh, there should be a comma. And again, this is going to be a token with a kind of token kind operator. And a span of 1, 1. No full stop, and close the token up. So that's the easy bit. What else? Yeah, okay, so here, this is going to be a token, same kind of thing, with a kind of token kind operator. This kind hack, I find it a bit hackish, but I don't have a better idea right now. So span, again, we're going to go 1, 1. We could do better than this, surely, soon. Otherwise, this whole thing's a waste of time. We've got to do better than this. All right, what else? 76. Yep, another token that we're creating here now. It's an int. Token kind int. And a span, again, of 1, 1. Leaving ourselves stuff to fix. Okay, what else? Okay. Oh, our token got moved when we tried to when we did the try from. So I guess we probably want to try from on a reference to a token. No, the problem is we don't want to have to copy the string that's contained in it. So these strings are really causing us trouble, aren't they? The thing is, it's gone by this time because it got converted into a result. We consumed the token when we did the try from. So I could like clone it first, and then that just feels really bad. So I guess try from should take a reference. Or the error part. I guess the error part should give us a span. That would work. It's a not operator token. If we included a span in that not operator token, like this, that would work. So let's go and fix the not operator. This is interesting. It might go wrong because it feels a bit innovative, but we'll see. So if we can find a not operator token and say it should tell you the span of where things went wrong. That would be helpful. So in order to do that, we need to get the span from value like this. Maybe we'll need to clone it or something. But yeah, this should be matching on value.kind, and these should be token kinds that we're now matching on. Like this. And that looks okay. What else? Similar kind of thing. And again, we're going to want not leaf token to have a span in it if we're going to do the same trick. Not sure whether I should be a stronger type than just this usize, usize business. But yeah, span on this should be value.span. And these are token kinds, aren't they? All right, where are we at? Span is not used. Well, that's okay. We'll get there. We'll get there. Okay, first of all, have we broken everything? No, things are still working. Excellent. So back to the parser errors. We should now be able to use the span of the error like this. And we can get rid of this, and we can use self.file contents. So I'm editing a different error here. I thought I was editing the same one. So the one we must have been editing before was this. Oh yeah, we've already got e.span.into. All right, so I'm panicking now because I'm writing code without tests. So let's write ourselves a test for the 3.3 case. That's it's a good thing I wrote that comment, isn't it? So something like parsing two adjacent numbers is an error. So 8 and 21 should not. We won't use parse v. Let's look at how we did this in the Alexa. We might need to wrap this up in some kind of helper function, but yeah, we set the thing to say don't use color, because the error messages go mad if you use color. And then we did some lexing, and then we got back an answer which was we did an unwrap error on it and got back. It shouldn't be called token. This is not a token. This is an error, right? Yeah, so that is a bad name. Let's call that error. And that too. But yeah, we're going to do something similar to this in our parser. Like this. So first of all, turn off color. Maybe we should wrap that up in a function. Then do something, and then the answer should be a decent error message. So instead of lexing something, we're going to be parsing something. What did I say? 821, didn't I? And in order to parse it, we first need to lex it. And then call next, and then unwrap, and then unwrap error. No. Then unwrap, because it does parse okay. It just doesn't. Sorry, it does lex okay, it just doesn't parse. And parse takes two arguments now because it takes the file contents first. So I guess this is a little odd. And it's going to happen like this. Is that right? Oh no, it shouldn't be. We should be. Yeah, we should be collecting. Yeah, basically, I want to iterate through these, but this iterator has results, and I want to kind of unwrap each one. So maybe I could just map it to a token, a result of token, which I can just unwrap. Maybe. Yeah, so basically we're saying Lex gives me back an iterator of results, and I just want to unwrap each of them. So now we've got an iterator of tokens. That seems to be okay. All right, so now this is not, our error message is not going to look anything like this, is it? But it should give us an error message, hopefully one that looks right. We got that install error. Okay, it looks like this miette thing can only happen once, maybe, and we're doing it every time. So let's, for now, see if this test runs at all on its own. So we'll just run the test like this, and then we have to figure out how to do this with miette. All right, so look, it worked. And it said, reached end of file mid-expression. That's the error message we designed. And then it says, look, here. So let's try this and on the command line. Look, it's working. Oh no, it's not quite working, is it? Because it's complaining about this token. It should be complaining about this token. So what have we done wrong? But also, how are we going to make miette behave the way we want it to? Alright, so where was it? It was 3.3 is not valid. So we said E. which is, yeah, that is right. So it appears to be that oh, you know what? We haven't actually put in the location. It's just saying 1, 1. Okay. So we shouldn't be getting the location right yet because we haven't actually supplied the location in the token. So they're all just saying 1, 1 for now. Okay. So where are we at? We've got this problem with Miette. So I think what I'm going to do for that is I'm going to stop recording for a second, figure out how to do this silly Miette thing, and then I'll report back to you and we'll carry on, because I don't think you want to watch that. So speak in a sec. Okay, I'm back. I think I've figured it out. Basically, I've written a little utility function that can go in all my tests to just turn off color for Miette, which is what this code was doing. And what it does is the same as what it did before, except if there's an error from it, it ignores the error. So my guess is if you call setHook twice, it fails. I tried it out, in fact, and if you call it a second time, it seems to fail. So we'll assume, like, if someone's already called it, then we'll assume they did the same thing as us and turned color off. So this isn't a greatly scalable thing, but it works for our use case because we only have one thing that we need to do, which is turn the color off. Maybe this should be called Miette, like prep for test or something like that. Anyway, point is, just ignore the errors and we're good to go. Everything works. Would that were always the case. All right, so let us try and see whether our error message, whoops, is coming out the way we think it should. So reached end of file mid expression is the correct thing for us to say. And at the moment it's reporting 1, 1, and the contents of the file are 821, like this. So yeah, it should say here, not this character, I guess. So it's looking something like what we want. For some reason, it's putting it here instead of pointing at the first character. It's pointing at the second character. Not sure why. But anyway, the position is currently wrong. So the fact that this test is failing is good. What it should be showing is that the second token is wrong. No. In fact, this one is reach end of file. So this is like special. It should be somewhere like here or one after here saying, oh, look, the end of the file has a problem. So let's find where we say reached end of file mid expression, because I guess that's something about EOF. How many unexpected EOFs are there? Well, hold on. This comment doesn't make sense, does it? Is this an end of file or not? What's happening here? Let's think about it. So we got another token, and it wasn't an operator token. So this is not an unexpected EOF. This is an unexpected token, I guess. And the position should be on that second token, which is this token we've just pulled out, token. So it should have got into E. But tokens don't yet get positions given to them. So let's give tokens positions when we create them and see if we can make this work. So I guess we want to test for tokens having the correct span. So let's parse it. Let's select some tokens and let's assert that they should have the correct numbers, which I guess is 1, 1 for this. So this is going to take in a span, which is going to be a pair of U sizes. And I think well, let's try and figure out what Miette wants us to provide it for. Was it a span? We called it a source span, I think. Yeah, you can create a source span with a start and a length, And if you create one from a pair of use sizes, yeah, it says start and length. So as far as I can interpret that, that means that the place that we were just looking at, where was it? Could have sworn I added that to one of the tests, but I have no idea which one. Oh, this one, yeah. So start and length should be 1 and then 2, right? Because it's 2 characters long. And then 1, 2, 3, 4, and then this one should be 4 and 2, because it starts at position character number 4 and it's too long. Right, and then this one will be 1, 2 as well. And this one is 1, 1. And this one, oh, we're not doing the operator yet, but anyway, this one is position number 1, 2, 3, 4, 5, comma 3. And then, while we're here, we better do operator as well. So operator is going to be position 1, 2, 3, and it's 1 long. And we better change operator to actually take in the span and provide it. And thank goodness we're in a language which checks all our function signatures so that we can find all the places that call this function before we asked for this argument. Right, so this one's pretty easy. 1, 1. What else? Again, 1, 1. Now we're not yet going on to another line or anything, so we haven't done great work here. I guess we could just stick a new line in here. And I think this will already pass the test, but we can check. And it's actually going to be the same. 2, 3, 4. It's still going to be the same coordinates, but just having a new line in there just makes me feel better about the idea that we might be doing it right. Now, it's not correct yet because we were always making it be 1, 1, right? So when we're actually lexing and we create a token, we're currently just hard coding 1, 1. So we need to do better. And that means we need to know where in the file we are while we're lexing in bytes. But that's okay. We have that because because when we do lex errors, we are actually giving the correct location already. That means that we have it in self.chars. So it's going to be something like self.chars.bytes. And then it's also going to be based minus the length of this thing, which is len. Len is the length in bytes, isn't it? Yeah. Yeah. So let's just get hold of the length first. Let len equal ret.len. And it's going to be bytes minus len, comma len, maybe. And we've got to figure out where else are we also setting a span. So here we're setting the span of the operator, and that should be self.chars.bytes minus 1, comma 1, because that operator happens to have length 1. So perhaps we should be more careful and actually calculate the length, because later the length might be different. Let len equal op.len, and now we can do the same kind of calculation we did before. I hope this is right. Should probably be checking as soon as possible. Oh, len is op is a char. We're turning it into a string here and getting its len. Ah. All right. We'll use 1 for now. And we just bear in mind that later we might need to do some work here if we find operators that are longer. Okay, that was all the places we needed to change. Oh, hold on. Is this 0 based? That would explain why some things were a bit weird for me. Okay, so let's try 0 based and see if it comes out right. So these will be all at 0th position. And then take off 1 off here as well. Now, we'll have to check that this actually formats it right, but that would explain why it looked wrong on the screen when we had a 1 there. I don't know why I thought it was 1 based. Most things are 0 based, but I guess I think of characters as being 1 based quite often. Okay. Right, what now? Only a couple of things failing, so things are looking better. So, line 166. Yeah, so this should be 0, 1, and then 2, 1, and then 4, 3. So what is it actually? It's going in as 1, 1, 2, 1, 4, 3. So that feels to me like that first one. I've got hard-coded 1, 1 still. 1, 1. Not here. Something about like the first token that we find. We'll get a character, and then we go all through and we create a thing. Oh yeah, and then len. Oh, that seems like that should be right. There's only this one place. Where the right hand side is a 0, the left hand side is a 1. So which one is it? Right, so 166 and 153. So what is different about these ones? 166 and 153. I think it might be that they're not. No, I was going to say they're single characters, but they're not. It's that it's the first thing we lacked, but I don't think that could be it. I mean, how come the others are okay? Or are they? Are there others? Yeah, there are. So there's these. And they're all fine. Let's just try a longer one, just to be sure. Oh, that also went wrong. That's interesting. Oh, because I typed it wrong. Because I typed it wrong. So, we're expecting this error because we haven't yet figured out the error messages, but these two are not coming out the way I expect because they've got the wrong position for that initial. It's when it's a. No, it's not only one character once. It's a 3 and a 17 that are somehow calculated as being in the wrong place. And other things. Yes, it's when there's something else after it that we go wrong. And it's probably because we're consuming the space and including that. Somehow. Yeah. Okay, so where do we consume that space? It's when we're reading in integers. And we found something that's not included. So let's just figure out. Oh yeah, bytes has gone one further along. Yeah, so I guess we could just -1 here. I guess we need a comment explaining that. Oh no, it's only when we hit the wrong type of character that we need to remove one. So this will be something like we break out saying -1. Oh, no, we need to modify variable. Stop trying to be clever. Okay, so this will be pos offset or something like that. Then before we start, pos offset is 0, and then we add pos offset to our position. And I guess we need to say that that is an I32. And then, oh, this is so frustrating. All right, let's just say we want to be able to take it away here. Is this going to be allowed? It does seem like you can take away a usize from a usize, even though that might turn out negative. And it's okay with it. All right, so that's fixed all of our offset problems. So basically the problem here was we consumed an extra character here, which we're going to have to deal with at some point, by the way, because it might not have been a piece of white space. So we're going to have to be clever about this later. But for now, we assume it's white space, we ignore it. But that means that self.chars.bytes is 1 further along than it otherwise would be. So if we take away 1 from bytes, we're back into where that token actually was. All right, so now we need to make our error message look how it should look. And parsing two adjacent numbers is an error. It's currently saying unexpected token, which is right. It shouldn't be saying reached end of file mid-expression. So let's look at parser.rs240. And it shouldn't say reached end of file mid-expression. It should say unexpected token. Unexpected token. And it should say it was here. So close. It should say this token, yeah. This token. Now, what else is different? That thing. Oh, yeah, it spans. Yeah. Oh, look, it's really nice. It should be whatever that symbol is. Like so. And now it's looking almost exactly right. And the difference is that it's standard in. It's position 3. 1, 2, 3. Position 3 on line 1 of standard in. And there you go. So now we have a nice test that checks that we do actually point out that two adjacent numbers are wrong, and it gives us a decent error message. So there's other things that are wrong as well, like just getting to the end of the file without finishing the operator. So 8+ is just not an okay thing to say. So this is parsing. This is like incomplete expression is an error. And this now should say like reached end of file. Reached end of file mid-expression. And we want to adjust exactly where we say this error is, I think. So we've got a bit of a fix to do here. Because I think it needs to be at position 1, 2, 3, 4. Like that's the end of the file, right? So it should be 4. And this should be 8+. And we may not be allowed to say like one past the end here. So we might have to just do the end of the file. But yeah, currently we're moaning about 1, 2. I think we're moaning about like this place here, I guess. So that seems really wrong. Oh, and we haven't actually provided. We've still got this to do thing here. So got to fix that. So to do. That should be file self.file contents for sure. And then this should be this. And this should be, again, it's going to be the arrow that's going to give us that token position because we've consumed the token already. This was an unexpected token. Yeah, so this is how we're going to test for this. This is like anything that wasn't a leaf token. So I guess just parsing, just a plus would give us this error. So let's try that. Just a plus on its own. But later that's going to be okay. So that's a bit irritating. But anyway, starting with an operator, we can change it to a different operator that's not allowed later. Is an error. So this will just be plus. That'll do us. In fact, let's just say plus 156 just to make it a nicer looking error. And this is going to be, it's going to be some other error. So we'll get there. But that wasn't even the thing. We just got distracted by more to-dos, because this is the error we're actually currently trying to fix. Self.file contents. And again, the error should give us a span. Oh no, in this case, I guess it should be the token that gives us a span, and then we might want to add to that. No, what is it? Left. All right. Yeah, we didn't get a right, so it'll be, yeah, there's no more tokens, so it's going to have to be left. And then we want to move it a little bit. Leaf token doesn't have a span, but it needs to have one, I'm afraid. Unless we can find actual... No, we're passing in a leaf token. So, yep, leaf token's got to have a span too. So all kinds of things need to have spans. And that means it's not an enum. Oh, really? I guess. That's so painful. Okay, there's a struct called leaf token, which has a kind, which is a leaf token kind. Doing this again. And it has a span, which is a pair of usizes. And I really wish that I'd done some kind of type def of this. So if I change my mind, and then enum leaf token kind, like so. And we've got to make it debug and partial eq. And when you create a leaf token, it's going to create a leaf token with a kind of this and a span of whatever you passed in. And you're going to have to pass it in. usize, like so. And now we just follow the compiler. And this needs to be match the leaf tokens kind. Well, just make it public. Obviously, it should be public. And import that. More to-dos, we'll get there. and again, match leaf token kind again. And keep going. I think that should be what are we doing? Yeah, this should be using value dot span. Okay, now leaf token. Oh, now we're wanting to use the int function in production code, which is fine. That's kind of, I was hoping we'd get to this. And oh no, okay, we're copying the string across, so we won't do that. We'll make it we'll have to explicitly create it and say its kind is a leaf token kind of int, and its span is value.span. And that's okay. Right, what's next? Now here we are expecting to find this was at 0, 1. Yeah, so anytime we make a token, we've got to say where it is, which is totally fair enough, but it's a bit of a hassle. 0, 2. And this is 1, 2, 3, 4, 5, 6, I think. 6, 1. It's quite nice that we're testing this out properly. What have I done? Not enough brackets. Okay, that seems to be all the compile errors. What about the tests? They're all failing. It's a nightmare. So this token only has a length of 1 according to this, which is a very pity, isn't it? Where are we? 2, 2, 3. Oh no, I got it wrong. The code got it right. Good. Now in this case, oh, it should be 5, 1, not 6, 1. That's probably right. We'll double check it. 2, 3, 1. So this is 0, 1, 2, 3, 4, 5. Yeah. Okay. Again, I got it wrong. Computer got it right. And then we've got these errors, which is what we're trying to fix. So that's good. That's good. Okay, so run it all again. Just the 2 errors. Let's start with the one we were working on, which was 9271. Well, there should be an N on the end of expression. That we can do. What else? Yeah, it's pointing at it's pointing at 1, 1. Interesting. So it's pointing at I think it's pointing at the left-hand token. That doesn't seem right. So let's try and fix that. So this is reached end of file mid expression, which is, that's an EOF type. How many EOF types are there? Oh, there's only one place where we do this, so it must be here that's going wrong. And yeah, it's complaining about left, whereas we have just found a mid token, haven't we? Oh yeah, we should, first of all, we should be using operator. That would help instead of left. But even that, we'd ideally like to be slightly further on. Oh, we need, okay, operator token needs a span. All right, we've got more to do, folks. Sorry, it's painful. There's a structure called operator token. Hopefully we won't do too many of these refactors again, but yeah, there's an enum called operator token kind. And operator token has a kind, and it has a span. And that will cause some breakage. So this should be match operator.kind like this. And that means kind needs to be public. And span needs to be public. And we need to make a self with a kind of operator token kind plus, and a span of what we passed in, which means we need to pass in. Like so. And this needs to be partially equalable. And everywhere else where we do it, what's the problem? It seems like that was not actually the problem. What's going on here? I mean, we should import Miet, but diagnostic, but have we not already? I'm a bit worried I've like deleted a load of code. Okay, so when we're creating an operator token, we need to create it like this. Its kind is operator token kind plus, and it also has a span, which is value.span. Where next? Yeah, now plus needs to take in the pair, and basically what we're saying is the position of plus, which is 1, 2, 3, length 1, like so. That's it. Back to our test failing, hopefully. Okay, so now it's pointing at the plus of 8 plus. 0, 1, 2. No, it's passing one path, so maybe that's okay. Let's have a look at that. Parser 9283. It's pointing at 1, 3. Oh no, that is the position of the plus, which I think is okay. Like, it's the last token in the file. If we try and point one past the end, I think the Miet gets annoyed if you point it somewhere that's not in the file. So I think we'll live with that. And then here it's complaining about how it should be saying unexpected token, because you can't start with a plus. Yeah, fair enough. Unexpected token. And it should be right at the beginning. So 1, 1, I guess. It is 1 based here. That was partly what confused me. And it should say this token. Here we go. We have error handling that looks decent for all of the problems that we could get whilst parsing. I think I will make similar changes for evaluation, but not do it on video because I think it's getting a bit dull at this point. And then we'll get back next time. I wonder what we'll do. Maybe being able to lex, parse and evaluate some more interesting expressions, like maybe even a statement that is a variable assignment, like let x equal 3 or something like that. That would be pretty cool if we could make variables. So that might take us a few videos, but hope you're enjoying. We'll get, like I say, I think the next video will be a little bit more fun than error handling videos are never going to be the best ones, but I hope you still enjoyed it. See you next time.